Hello everyone and welcome to today's talk, What is Chaos Engineering? And before I get started into this topic, let me briefly introduce myself. My name is Jürgen. I am the developer engagement lead for Microsoft Austria, and I'm also an open source project maintainer. If you want to hit me up on social media or on GitHub, if you want to find my projects, this is my social media handle. Feel free to look it up. So let's jump into the topic. What is chaos engineering? And chaos engineering is actually an engineering discipline. And what we want to do here is in kind of a controlled way, we want to introduce faults into applications and then to analyze what is the impact of these faults or the impact of any kind of chaos or problematic situation on our applications, on our full stack probably. So it's not that we do anything ad hoc, but it's really an engineering discipline, and it starts by forming a hypothesis, by saying, okay, I want to have a response time of 200 milliseconds, for example. And then we start with an experiment. What if in a high availability setup, if we remove one of our nodes, for example? So can we still hit our target of those 200 milliseconds that we actually want to hit? So we would analyze what is the impact if we remove a server or a node from our stack. And once we analyzed and we finished our analysis and we came up with a result, we can then decide how to improve, probably doing something with the load balancer, introducing caching, or whatever we want to do. So, and this is especially crucial for applications that are living in the cloud, but also for more traditional, maybe monolithic applications. And if we think about microservice applications, that each microservice, if just one microservice has an outage, it might impact our overall availability. And the other thing that I really want to stress here, because I've been a developer for, myself for quite a long time, is every single outage really impacts and steals away developer time. So if we think about bug fixing, if we think about improving some configuration, if we think about making the application a little bit more stable, then it really takes away the time that we actually want to put into to improve the product, to work on new features. So we really have to think about this quality and resilience in our applications. And talking about the cloud, here we need to design our applications so that they can handle failure. I will be talking a little bit about Kubernetes in this talk. So if you've heard of it, that's great. If not, you can just think of it as like an orchestration layer for your containerized applications. And this orchestration layer might even move around and shuffle the workloads from one server to the other. This is all done by this kind of orchestration layer. So if these kind of layers, they decide to move one workload from one server to the other, the workload has to kind of be prepared. So we really have to think about scaling, about shutting down applications, moving them from one server to the other, failovers, load balancers, all these kind of things. So in the cloud, this is really important, and we can improve this with chaos engineering. One thing that's also really important, and for a, let's say, developer audience, we usually think about our application. Also myself. I care most about my applications that I write, but the application is like only the top of the whole thing, because you have usually a lot of dependencies, either in your stack or also on third parties. If we talk about in the stack, you might have some dependency on your database. You might for sure have some dependency on some kind of compute in your infrastructure. So I put this here on this, let's say, pyramid. And even if you remove a couple of those layers that say Kubernetes, if you're not working with Kubernetes, that's totally fine. Remove a couple of them, but still, you will always have the infrastructure. You will always have your applications. And depending on your stack, you might have a little bit of other layers in between. So just keep in mind, each of those layers could fail, and how will your application react to this? So your app is really only at the very top of this. And one other thing that we have to keep in mind, that we work a lot with assumptions. So when I say we work, I mean like we as developers. We work a lot with assumptions, and I do this myself as well. Because when I develop my application, I usually do not care about will the network be available when I run my application. Of course it will be, because like my job was just to write the application. My job was not to figure out if the network is available. But then I always kind of work with the assumption that I do have enough compute. I do have enough storage. Like the other applications, other third-party dependencies I communicate with, they will respond. So I have a lot of kind of assumptions, and you can even put those assumptions into different buckets. So there are things that we know, and we know also some things that we don't know. But just keep in mind, there might be things you've never thought about, and design your application to be resilient. Design your application in a way that if there are outages that are outside of your scope, that your application can still respond in some kind of way. So how can we measure and actually also improve resilience, and by that also the quality of our applications? So we saw this already a little bit in the beginning, but here I put it into a little bit different words. When we want to measure the resilience of the applications, we really have to start with some steady state conditions. And by that, we kind of define some hypotheses. Again, let's take the example of those 200 milliseconds. Our application has to respond within 200 milliseconds. That's where we really want to start. And now we're introducing a fault. We introduce, for example, let's take it again. In a high availability setup, we remove one of our nodes. Say we have 3 in the beginning, and in this experiment, we remove 1. So when the application is now under heavy load, can we still meet our SLOs, our service level objectives? I will just talk about this in a second, but can we still meet the objectives? In our case, 200 milliseconds of response time. If we can meet this, we can say this app is resilient to the failure if one node just dies in our high availability setup. If we cannot meet our SLOs, then we have found a weakness and we can try to improve it. For example, scaling up the whole application to more nodes, or introducing or configuring maybe the load balancer so it should fail over to the other nodes that are still available. And the concepts to measure those are, we usually borrow them from the site reliability engineering, let's say community or space. They have come up with great concepts and we can really make use of them here. 2 I want to highlight. The first one is the service level indicator. And I've kind of simplified it here a little bit, but we really can think of some kind of metric that we can measure. For example, the error rate of login requests or the response time of the front-end service. And then we can put on some targets for our service level indicators and say, now the response time must be faster than 200 milliseconds over a 10-minute period, 30-day period. Or in this example, the login error rate must be less than 2% over a defined period. So we can now measure and define a target for our goals and to measure the resilience of our applications, and then define if we met it or not met it. So once we have kind of this concept and framework for this, how can we introduce chaos? Basically, there are a lot of different tools out there and they work on different layers of your stack. So you can introduce chaos directly in your application code. That would actually mean to fiddle a little bit with the application itself. And here, chaos is not bugs. So please do not introduce bugs in your application, but chaos would really be maybe in your application code to introduce some kind of like pauses or breaks or even some kind of delays. You could also do it on the operating system that your application is running on, or some kind of other cloud resources or other resources like the network, or maybe the infrastructure, coming back to the example of the server nodes that you might have or might not have. And the idea of chaos engineering is that you're not doing this ad hoc just by removing or turning off a machine in some cloud provider, but actually to have a framework or to have software that is doing this for you, that you can that you can configure in terms of a infrastructure as code approach, where you really have a declarative definition. And there are a couple of tools out there. I just want to mention here some. You might have heard of Chaos Monkeys. I did not put it up here because, at least to my knowledge, it's not available anymore. But this was one of the first invented by Netflix. So they came up with the idea of chaos engineering and they called it Chaos Monkeys. And then the more prominent examples as of today are two very prominent open source projects, Litmus Chaos and Chaos Mesh. The latter is actually also the foundation of the offering in the Azure Chaos Studio that was building upon this open source project Chaos Mesh. And then there is another one, Gremlin. It's also a commercial solution, and it's out there also for quite some time. They all have in common that they already provide you a library of chaos actions, like exhausting the CPU, exhausting the storage, removing the network from your stack. So all of these kind of chaos experiments, they have it built in. You can start it, you can stop it, you can orchestrate it with those tools. So make sure that you make use of those tools and not coming up with any solution by yourself. And before I close it, I just want to leave you with the idea that when we talk about chaos engineering, we actually want to move from ad hoc chaos experiments to chaos testing. Same as with load testing. So you would not do load testing only once a month, but you would do it maybe as part of your pipeline. You would do it in a regular way. You want to make sure that each new feature you develop, each bug fix you release is also load tested. So you know your application is still responding or can respond also under heavy load when a lot of your customers are using your applications. The same is true for chaos experiments. So we don't want to do it ad hoc, but we want to include it in the pipeline. And the open source project that I'm also heavily involved in is called Captain. Here, what we did is basically to introducing a dedicated stage. We called it here, just in the example, a chaos stage. Think of it like you have production, you might have pre-production, you might have testing, you might have dev. Just think of it as a new stage. We called it here chaos. And the whole idea is that each time you run the pipeline, you deploy your application into the stage, you run your load tests, for example, JMeter tests or whatever. I heard, I saw a great talk also here in this format of the Tech Talks using K6, for example, for load testing. You could use K6. You could also use JMeter, use whatever you want, and also include your chaos testing framework. Once you run your tests, the tests are finished after 10 minutes, 1 hour. That's totally up to you. Then you trigger the evaluation of the service level objectives. Of course, you fetch the metrics from maybe Prometheus, maybe Dynatrace, maybe some other tool that you might have. And then you evaluate those SLOs. So the whole orchestration of this kind of sequence can be done by Captain if you want to use it. We've built this already in this open source project for you, so it's ready to use there. But the idea is really moving from ad hoc experiments to a more mature, a more kind of engineering approach, using this as part of your pipelines. So with this, I'm already closing, and thank you.